Hello, let us look at some review questions for upcoming exam. So first, I want you to look at this question. Square root of x minus 4 equals 7. How do you find the value of x? So what we want to do is, this question, notice that we want to undo square root. We can do that by squaring both sides. So then on our left side, square and then square root will undo each other. And on my right side, it becomes 49. So then as we add 4 to both sides to get rid of negative 4, then x must be equal to 53. So that means choice 4 becomes our answer. Alright, let's look at the next one together. So same kind of concept here. We have radical on one side, number on the other. To undo the radical, we're going to square both sides. Then on our left side, we get 1 minus 2x. And on my right side is equal to 4. So then, by subtracting 1, we realize that negative 2x must be equal to 3. So then x equals negative 3 over 2. Choice 2 becomes the answer. In case of number 3, what we have to do first is that we have to get rid of 2 by subtracting 2 from both sides. What this one does is that it isolates the radical by itself. So we have square root of 2x minus 1 is equal to 3. Then, same as before, we're going to square both sides to undo the radicals. Then we get 2x minus 1 is equal to 9. Then by adding 1 to both sides, 2x must be equal to 10. Then x must be equal to 5. Choice 3 becomes the answer then. Alright, let's move on to the next question. Same deal here. Number 4. Notice that we have minus 3 here, and we want to get rid of that so that we could isolate radical by itself. We can do that by adding 3 to both sides. Then we get square root of 2x minus 3 equals 9. And now we can square both sides just like before. Then we get 2x minus 3 must be equal to 81. Now, by adding 3, we get 84 is equal to 2x. Then x must be equal to 42. We got this one by dividing each side by 2. So choice 1 becomes our final answer then. Alright, let's move on to the next question. On number 5, we see the same deal. We need to get rid of negative 5 to isolate radical by itself. Now, we can do this one. And we end up getting square root of 3 plus x equals 3. Now, by squaring both sides, we get to realize that 3 plus x must be equal to 9. That's right, then x equals 6. Alright, let's move on to the next question. Number 6. Notice that radical is already isolated by itself. So, all we have to do is square both sides. Then we'll end up getting this equation. And by subtracting 1 from both sides, we'll be able to get this equation as well. Now, then how do you find the value of x? Yeah, that's right. We can factor this one, looking for a number that multiplies to 2 and add on to negative 3. What could that be? X minus 2 and x minus 1 equal to 0. And that tells us that x must be equal to 2 or 1, which is choice 3. Now, number 7. One difference on number 7 compared to the previous question is that we have x on the outside of the radical. That means we better check our answers. So then as we square both sides, then we get x plus 6 is equal to x squared. Since this is quadratic, what we're going to do is we're going to set one side of the equation equal to 0. By taking away x and taking away 6, we get to realize that x squared minus x minus 6 must be equal to 0. And as we factor, we get this equation. Now, then once we have this one, we're going to make a t-chart and basically find the value of x is equal to 3n negative 2. Now, then what we need to do is we need to check up on both answers. If I were to plug in 3, what do I get? In place of x, 3 plus 6, is that equal to 3? And 3 works out as you can see. How about negative 2? Negative 2 doesn't work out here because square root of 4 is not equal to negative 2. So therefore our only answer is choice 3. 3 alone. Alright, same kind of question. So we're going to square both sides. Then we'll end up getting this equation, setting one side equal to 0, just like before. Then we got a factor. Which two numbers multiply to negative 10 and add on to negative 9? Okay, negative 10 and positive 1. So then x must be equal to 10 or negative 1, and we need to check both of them. So we are checking 10 first by substituting 10 in place of x. Oh, wait a minute. Square root of 100 is equal to 10, so 10 works out. But how about negative 1? Then you realize that negative 1 doesn't work because square root of 1 is not equal to negative 1. So therefore choice 3 becomes our answer once again. Same kind of question, number 9 as well. So let's go through them together. Square both sides. And set one side equal to 0 by taking away 2x and 15. Now we got a factor. And find the values of x. Now check. So when you plug in 5, okay. Oh, wait a minute, square root of 25 is equal to 5, so 5 works. How about negative 3? And you can see that negative 3 wouldn't work because square root of 9 is not equal to negative 3. So therefore choice 2 becomes the answer in this case. Another question of the same kind. Square both sides. Set one side equal to 0. Then now we factor. Then find the values of x, 7 and negative 3. But we gotta check. So as you check, we get to see that 7 works. And then negative 3 on the other hand didn't work. So therefore our answer is choice 3, 7 alone. Alright. Number 11 is similar, but be careful when you square 3 minus x. So on our left side, we just have to undo the square root. We get x plus 3. But on our right side, when you square 3 minus x, we get 9 minus 6x plus x squared. All you have to do is make sure you know that this one is equal to what? 3 minus x times 3 minus x. You just have to distribute them. As you continue, x squared minus 7x plus 6 is equal to 0. Then once again, as you factor this one, we get to realize two answers, 6 and 1, but we're going to check both of them. So I'm checking for 6 right now. Now, on our right side we get negative 3 and 6 didn't work. How about 1? Okay, it seems like 1 is working. So therefore our answer is 1 alone. Same deal, number 12. Be careful when you square y minus 2 minus y. Then we get 4 minus 4y plus y squared. So once again, be careful. Don't forget negative 4y term in the middle when you square them. And moving everything onto one side, we get y squared minus 5y plus 6. Factoring once again, then we get to realize two answers. So we're going to plug in 2 and 3 in place of y's and see which one works. And 2 seems to be working. But how about 3? And 3 doesn't seem to work. So therefore our answer is 2 alone. Choice 2. Alright, let's move on to the next question. Number 13, we need to we have a equation with fractions. To deal with this one, what we have to do is we need to identify the common denominator. So here common denominator was x minus 3. So all we have to do is multiply by x minus 3 in all three terms on this equation. Yes, including 2 as well. Then we get to realize that x minus 3 cancels out in 2 locations. So we are left with 4x on the first one. Second one, we are distributing 2. Third one, we are left with 12. So then 4x equals 2x plus 6. Now, from here we just have to find the values of x by subtracting 2x, and therefore x must be equal to 3. It seems like that is our answer. Until we plug in 3, we plug 3 back into an equation, original equation, then we get to realize that denominator becomes 0. But we know that when the denominator becomes 0 in the fraction will be undefined. So therefore, 3 is not allowed. So we only had to answer 3, but since 3 is not allowed, then we have an empty set. No solution. How about here, number 14? What is our common denominator? Common denominator here is equal to 5x because it has to be inclusive. One is x, the other one is 5 times x. So we are going for 5 times x because that is in other words, least common multiple. So I'm multiplying 5x to all three terms. Now, alright, then x cancels out, we get 10, 5x cancels out, we get 3, equals 5x. Then we get to realize that 13 is equal to 5x. Then we realize by dividing it by 5, x must be equal to 13 over 5. Alright, so that becomes our answer. If you, since you have a calculator, you can put the value of x, 13 over 5, in place of x, and use the calculator to check it. That will be perfectly fine. How about number 15? In this case, yes, the common denominator is 3x. So same way as before, we're going to multiply by 3x in all three terms. And then look for the cancellation here. Cancel out x's, we get 12. Cancel out 3 x's, we get 2, and then middle we have 15x. By subtracting 2, we get to realize that 15x is equal to 10. Then the value of x must be equal to 10 over 15, which is 2/3. Alright, let's move on to the next question. In this case, what is our common denominator? Notice that here we have, what we have here is not 2 times x, but x minus 2. So when we are looking for common denominator, it will be simply x times x minus 2. So now we're going to multiply by x times x minus 2 in all three terms. Now, then x cancels out, we get 9x minus 18. X minus 2 cancels out, we get 9x. And then the last one is what, 12x squared and minus 24x. Alright, bring everything onto one side. Then 0 equals 12x squared. We get 42x. Why? Because we are subtracting 18x and adding 18. And we are simplifying that by dividing each one by 6, because 6 was a common factor. Then we can continually factor this one by 2 times 3 is equal to 6. So then which two numbers multiply to 6 and add up to -7? Oh, that is, technically we are looking at -1 and -6. So 2x squared minus x and minus 6x plus 3. Notice that then this is equal to 7x here, -7x here. Factoring out x because that was common. Then we get 2x minus 1. Factoring out -3, then we get 2x minus 1 as well on the last two terms from here. Then since 2x minus 1 is common, we factor that out, we have x minus 3 left. Now then 2x minus 1 has to be equal to 0. Then what's the value of x? X equals 1/2. And same thing for 3. Now, then as we check the values, we are checking 3 first. Then you can see that 3 works out. How about 1/2? Now, if this one is 1/2 is not that easy for you, then you can put that into a calculator. You get to realize the first one becomes 18, and second one becomes -3 over 2. But we get to realize the second term is equal to -6. Therefore, both of them works. So our answers are 1/2 and 3. Alright, let's move on to the next question. What's the common denominator here? It is in fact both of them, x plus 3 and x minus 4. So we're going to multiply, and 3 as well. We're going to multiply by all three denominators. To each term. And see how everything cancels out. Alright, so we get to see some cancellations. Alright, let us try to multiply everything out. So first one, 3 times 3 was equal to 9, and multiply by x minus 4. We get 9x minus 36. Second one is 2 times 3 times x plus 3. So we get 6 times x plus 3. We get 6x plus 18. Now 4 has to multiply to these two factors, then we get 4x squared, and then minus 4x and minus 48. Alright, so that's what we end up getting. If this one is, you can do this one on the side and then come back to see if this one is correct. And setting one side equal to 0, that means we have to get rid of this one by subtracting or adding, undoing all those numbers. So we get 0 equals 4x squared, because that's the only one that we have. And then we had negative 4x and then 15x coming over to the other side, so we get negative 19x. Oops. And then how do you the last one is negative 30. Then how are we gonna factor this one? So when you look at 4 and negative 30, we get negative 120, and we can see that 5 and 24, or negative 24, multiplies to negative 120, but add up to negative 19. And we rewrote our quadratic equations in this way, so that negative 19x can be written as a 5x minus 24x. Then since x is common in the first two terms, while negative 6 was common in the second two terms, and 4x plus 5 was common in those two terms now, and we get x minus 6. Then x must be equal to negative 5 over 4, or 6. Now we need to check. So I'm first checking 6 here, plugging in 6, and then see if we get 4 over 3. Now the first one is 1/3, second one is 1, and we realize that that works out. How about the second one? We're going to plug in negative 5 over 4, but you can use your calculator to check this one as well. So this is how I plugged in, and I calculated each fraction at a time. So the first fraction here that we see ended up being 1.714. Second one was negative 0.381. When I combined them together, it was that way. But 1.3333 is in fact equal to 4 over 3. So in fact that works out as well. So both of them are our answers. Alright, number 18. To do the completing the square, first what I have done was I brought 6x right next to x squared, so we end up getting this quadratic equation. But what we want to rewrite is giving ourselves a space for the completing the square, and then subtracted negative 2. Why did I add 9? Because 9 is needed, because what we have done was we got negative 6 divided by 2, and then square that. Then we get x minus 3 squared is equal to 7, and that's exactly what we're looking for number 18. How about number 19? In this case, when you undo the square by having the square root of it, we get plus or minus square root of negative 9. But as you can see, what is a square root of negative 9? That's plus or minus 3i. By subtracting 2, we get to realize that negative 2 plus or minus 3i becomes our final answer, which is choice 2. Now, number 20. And you may wonder, wait a minute, how do I do this one? Because I have 2 in the front. But did you realize that I can divide by 2 the entire equation? Then I'll end up getting something like this. But we know how to do this one because we basically did this one last time. Subtracting 2 from both sides. And then adding 9, because 9 is the what? Square of -3, which is the half of -6. Then we get x minus 3 square, which is equal to 7. Then we can undo the square root, square, by taking the square root of both sides. We get plus or minus radical 7. And then adding 3, then we get 3 plus or minus square root of 7. That becomes our final answer. Alright, with this one we're going to close up, and I'll see you later. Bye-bye.